So let's try some example problems on conservation of momentum. Let's recall the concept. The law of conservation of momentum states that if there is no external force acting on an isolated system, the total momentum of the system remains constant. What that means is within the system, one object can gain momentum and another object can lose an equivalent amount of momentum, but their combined momentum should always stay the same. So the principle in all of these problems is to set up an equation for total momentum before collision and total momentum after collision and equate the two. So let's look at the first problem. Question number 4. It says the driver of an 800 kg sports car slows down to 30 meters per second to check out an accident scene. And the 1200 kg pickup truck behind him continues traveling at 25 meters per second, bumping into the sports car. With what velocity will both move if they lock bumpers after the rear-end collision? So we have a truck and we have a sports car. So the car was moving at 30 meters per second, and because it suddenly slowed down, the truck that was moving at 25 rear-ended the car. And after the collision, they are both stuck. That means they are going to move as one unit. So we want to know what is the final velocity of this combined car-truck object. We know the truck weighs 1200 kilograms and the car weighs 800 kilograms. And so we can set up the equation as total momentum before impact equals total momentum after impact. So we know momentum is mass times velocity. So the momentum of the truck is 1200 times positive 25 because it's moving to the right. Plus the momentum of the car is again 800 times positive 13. It's moving to the right as well. Equals, because these two are stuck together, you can combine their masses, which is 1200 times 8 plus 800, and times the final velocity is our unknown. So this is how we set up the equation. So now we can solve for our unknown VF. So do the math and let's see what VF turns out to be. Did you get VF to be 20.2 meters per second? So the truck and the car move together as one unit with a velocity of 20.2 meters per second. Let's try another example problem. Question number 6. So there are two cars of masses 10 kilograms and 2.5 kilograms moving in opposite directions on a frictionless track with speeds of 6 and 3 meters respectively. So I have the 10 kilogram cart moving at, let us say, 6 meters per second this way, and the 3 kilogram cart moving at 3 in the opposite direction. So since it is to the left, I have to denote the velocity as -3. Again, the carts stick together after colliding. You will learn later that this type of collision where the two objects stick together is called as a perfectly inelastic collision. So they are stuck together, and we want to know what is the velocity of the combined unit. So again, applying conservation of momentum, total momentum before impact equals total momentum after impact. So we can write 10 times 6, which is the momentum of the first car, plus mass times velocity. So 3 times -3. Notice that this momentum is a leftward momentum because this object is moving in the opposite direction to the 10 kg object. So be sure to put the negative sign for the velocity. So equals, they are combined together, so their combined mass is, oops, I made a mistake here. So the mass is 2.5 kilograms times -3, and then the combined mass is 12.5, and we don't know the velocity, so let's call that as VF and solve for it. So if you pay attention here, the momentums are going to subtract from each other because they are opposite in direction. So solve for VF. So did you get VF as, let's see what we have, 4.2 meters per second. So in all of these problems, you're going to apply conservation of momentum. So draw a diagram to see what is the before situation, what is the after situation, and then apply the conservation of momentum equation to the problem, and you should be able to solve.